In this video, we're going to look at Worksheet 8, Question 6 from Engineering Math 3, Learning Outcome 2. This problem is an example of integration by substitution. So to begin, we need to identify what we would like to substitute out from this expression to give us a simpler integral, but also keep one eye on something that's going to allow us to express the integral entirely in terms of u, the symbol used to represent our substitution. And it may indeed seem tempting to pick the term that's inside the brackets, because we don't want to deal with a power 4 bracket, and that will be the case here, and we'll see why that's the case shortly. So we'll begin by letting u be equal to 3 plus root x. So we would rewrite our integral as integral between 4 and 1 of u to the power 4 over 5 root x dx. Now, of course, we know in this type of problem, we need to have this integrated with respect to u and the du here. We also need to get rid of this root x at the bottom. All of our terms have to be in u. And of course, we'll now follow the step we would always do, and we take the derivative with respect to x of u. So du by dx is going to be equal to, well, if we look at 3, that's going to reduce to 0, as any constant does when we take the derivative. And then we've got plus root x. And if we remember that root x is the same as x to the power of half, and so we take a derivative of an x term, we multiply by the power that it currently has, and we reduce the power by 1. So that becomes x to the power minus a half, or another way we can rewrite this is 1 over 2 root x. And already that's looking like something we might be quite interested in, because we have a root x term in the denominator of our integral after substitution. So finally, we'll write this as dx is equal to, and we'll just do a little bit of rearranging here. Du times 2 root x, and so we can maybe write this more simply as 2 root x du. And this is coming along very nicely. So before we swap over for dx for du term with this other substitution, because this is a definite integral, we also need to come up with new limits in terms of u. We can't just use the limits 4 and 1 there for integration in terms of x. So when x is equal to 1, u is equal to 3 plus the root of 1, that's 4. And when x is equal to 4, u is equal to 3 plus the root of 4. Root of 4 is 2, so that's going to be 5. So our limits of our new integral are going to be, instead of 4 and 1, they're going to be 5 and 4. So let's write this out with our new limits. We have integral between 5 and 4. We have u to the power 4, as we did before. We put this 5 root x in the bottom. It's about to disappear, well, partially. And our dx is replaced with 2 root x du. Well, we can cancel these root x's in the top and bottom, and we're left with an integral between 5 and 4 of 2 u to the power 4 over 5 du. And to again make our lives, of course, putting equal signs down the side here, so each step is indeed equal to line above. And of course, what integrals also allow us to do is to take any constant coefficients, so any numbers, and multiplying our expression outside. So we can take this 2 over 5 out here. We're quite happy with that. And then integrate between 5 and 4 of u to the power 4 du. And that's not something that particularly troubles us in integration. We have a very clear standard integral for u to the power 4. So we put in our square brackets, and that will of course be u to the power 5 divided by 5 between 5 and 4. That's going to be 2/5 of 5 to the power 5 divided by 5 minus 4 to the power 5 divided by 5. And we can I can take this up a little bit more, because what we can do is we can take out that common factor of 5 as well. So we're going to have 2 over 25 here, and that'll be 5 to the power 5 minus 4 to the power 5, and I'll just put that into the calculator rather than, you can, these are things we can multiply. Maybe we will just do that. 5 to the power 5 is equal to 3125, and 4 to the power 5 is equal to 1024. So we're going to have 2 over 25 multiplied by the difference between these two numbers here. That's going to be 2101. And so carrying out the final step of our multiplication, we're going to have 4202 divided by 25. And since the top's definitely not divisible by 5 and the bottom only has a factor of 5, there's no further simplification we can take. So unless we want to express our answer in the decimal form, and there's no particular need to, since this is an exact answer, this is the answer to the question of this integral here between 4 and 1, 3x plus root 3 plus root x to the power 4 divided by 5 times root x. That's the answer there.